This is Orion, Meta's augmented reality glasses prototype that they consider the most advanced piece of personal technology ever created. It's taken them years and countless millions in R&D to get to this point. A 98-gram pair of glasses with an optical display system that can put holograms almost everywhere your eyes can look, and an input system that seemingly reads your mind. The catch? Each Orion prototype costs about $10,000 to make, and Meta's only making about 1,000 of them for internal development. It's a kind of device that they call a time machine, and we're one of the few people at this year's Connect conference to go hands-on with one. To dive deep into how Orion works, what it's like to use them, and what this time machine reveals about the future of augmented reality, let's start with a conversation I had with Boz, Meta's Chief Technology Officer. Okay, Boz, we're here to talk about Orion, or is it Project Orion?
Orion. We're calling it Orion.
Orion. In conversations with some of the teams here, like displays research team, I know you guys sometimes create products that you think of as time machines, right? Where it's like put the best and regardless of cost, just to see what it would be like if your team and researchers and developers. Is this representative of what you would call like a time machine?
Yeah, this is an incredible piece of work. When we started this program, we had hoped it would be a product that we could ship. But we gave ourselves only, this was even 5 years ago, we gave ourselves only a 10% chance of being able to build one. We really had so many new technologies that we were pioneering, at least 7, probably really, I would say 10 technologies that had never been done before.
Yeah.
So we really weren't sure if it could even be built at all. And so the product was, this idea of it being a product was our goal. We weren't sure if we'd get there. Well, we ended up building not just one, we ended up building quite a few of them. They work, they're spectacular. We are like overjoyed with the devices. Ended up not being cost effective as a product. And so, yeah, it does stand as a time machine. But a lot of times when we talk about time machines, we're talking about, the version of this that's a time machine would be on a bench,
right.
The size of this room.
Power supplies.
Plugged into all kinds of power with lasers.
This is wearable.
So this is something different. We're going to call this a prototype. And what's important for us is this is a fully working, it's got an operating system, it's live, it's internet connected. And we now have a device that allows us to develop software and develop an intuition around what software experiences will be great for what we believe is the type of device that will replace the phone someday. And yeah, it's hard to describe the emotion I went through the first time I tried it on when the software was running. It was a few months ago. And the team came in, and the team was very nervous to show this to me because it's been obviously 5 years and who knows how much money in the making. And we are, so they're just apologizing for everything. They're just, I know that pixel's a little rough and we'll get the color uniformity right. Meanwhile, I'm having one of the greatest experiences of my professional career.
What was about it, that experience that was so different than previous MR, AR?
It's a full color, wide field of view display that's responding to neural interfaces, that you're sending through your wrist.
Yeah.
And it was very responsive. And you're looking at videos and you're doing video calls. And it's spectacular. It's just spectacular. Just you feel like it's a sense of real wonder. And so but of course the team has been in it for all this time. They see all the problems. It was such an early demo that the compute was they kept replacing a cold soda. They kept putting new cold sodas in the compute because they hadn't even done the work yet on the thermals. So they were just trying to cool it down with cold sodas. But it was a glimpse. And even just in the last several months since I did that demo, it's now gotten to this point where it's a fully functioning system. You could use it. You can walk around. You can spend, it's got a 2-hour battery life. You're walking. You can spend time in meetings. You're able to have a really rich computer available to you without taking anything out of your pocket, without losing the context of where you are in the world, without breaking eye contact with someone that you're talking to. It's spectacular.
And bringing new context.
Oh, absolutely. Absolutely.
So let's talk about some of those technologies. You said 7 tech. We don't have time to dive into all of them, but obviously the display system's a big part of it.
The displays are really, really important when I have a very fun, clear demo here. And so you've got micro LED projectors, which are putting out tremendous brightness, hugely efficient micro LEDs. All 3 colors, RGB. They're putting out hundreds of thousands of nits. But of course, to have a really big eye box, so you don't have to have this thing where you can move the glasses on your face and you can still see the image, you're doing pupil replication. So you're shooting those photons in lots of different places towards the eye. And so it's a big discount. And then, of course, there's inefficiency and there's just loss as photons escape the substance. And so you've got these tiny projector, which we completely invented ourselves, including manufacturing the micro LEDs ourselves. You're shooting it back towards the waveguide. The waveguide itself is nano etched into silicon carbide, which is a novel material with a super high index of refraction, which allows us to minimize the lost photons and minimize the number of photons we capture from the world. So it minimizes things like ghosting and haze and rainbows.
All these artifacts while giving you that field of view that you want.
Well, it's not artifact free. It's very close to artifact free. Like you'll get your own experience, and you actually, it's amazing. The optical clarity, the see-through clarity of these is really, really high. And the image is super wide field of view, full color, and it's tremendous. So you've got these two systems alone working together were an immense amount of investment and cost, each of them requiring 2 or 3 different new technologies to come to bear. Keep in mind, like red, blue, and green, just getting red micro LEDs is hard because it's a very long wavelength to generate such a small space.
Right.
And then silicon carbide, manufacturing it and growing the crystals large enough and machining it is tremendously difficult. And then you have to mount this whole thing on magnesium, rigid magnesium frame. It's lightweight, good thermal properties because you don't have much thermal dissipation space here. So it's such a small device.
It looks packed.
And it's also rigid because right now we don't have disparity. So you don't want to you want to minimize any deflection between the optical elements to keep the binocular image looking correct in your field of view. These are all things that we already have plans to improve for the next version. So you get to this version 1 and you figure out, oh, we can actually figure out how to do disparity correction. Oh, we can actually figure out how to put the projector in from behind. We can actually make this thing thinner. And so this thing has, we have between the system, between this and the stage that powers it, this puck, more than 10 pieces of custom silicon, which have miniaturized our routines, taking them from for example, the Quest system, where they might be, the Quest has relatively generous thermal envelope compared to these glasses, taking them from thousands of milliwatts down to hundreds of milliwatts, or even in some cases dozens of milliwatts, to have this long battery life. The radio protocol, completely custom radio protocol, so that you're sending information over in bursts to minimize sustained usage of the radio, again, for thermal reasons, not for power reasons as much as thermal reasons.
Which is important for
again,
AI and continuously perceiving the world to give you
absolutely
those contexts.
The sensors, you've got all these tiny cameras built in. It's actually almost easier to see on this one, where the cameras are, there are 7 different cameras embedded in the frame that are doing the world sensing. The camera sensors are custom sensors. You need to have super high dynamic range. You need to have certain properties in terms of your ability to pick from the scene what you care about and focus on that. And then of course there's quite a few things that are shared between this system and our Quest systems. So the hand tracking, the eye tracking, spatial audio. And those pieces kind of jointly effort. But of course, doing the hand tracking in this kind of a form factor is tough. And then of course, at the end of all that, you've still got the novel interface.
Right. You guys made an investment in control labs.
You're not going to walk around in the world with controllers. Yeah. And you're going to walk around with your hands, but you're not going to walk around with your hands out here doing this. And you might even want to be able to control the system with your hands in your pocket or obscured. And so we've got these neural interfaces, which are just getting started, but it's this, when we started, you've seen the Control Labs demos. Yeah. This didn't used to be this small, let alone this attractive. And it's so comfortable. We've been doing these demos a couple weeks now, and people keep walking out of the room, not realizing they don't even realize they're wearing it anymore. So you're getting all these new technologies, and then you're trying to pack it into an under 100 grams, a 98 gram device that's comfortable enough that you would be willing to wear it for its 2-hour battery life, and hopefully attractive enough that you feel like, you could be taken seriously wearing these glasses.
That's important.
And so we just felt, when you look at that, 5 years ago, you can imagine, you're just thinking, man, if any one of these things is a swing and a miss, this whole system doesn't come together. That was the emotion. I have all that weight coming into my first demo with it, and I'm feeling that emotion of all that investment and all that risk, and the execution that it took to get to this point.
And at this point, and then developers can start figuring out what are the best use cases. But you have this idea that eventually you want this to replace the phone. So the things that people are doing on the phone, or at least the media and the type of interactions. But it's also AR can do more than what a phone can do. So what are the kind of dream scenarios? Like ideally, when a consumer version of this hits the marketplace, what's the utility that this brings to an average person?
Yeah, the thing that we didn't anticipate 5 years ago, which has changed obviously in the last 2 years, is AI. So 5 years ago, we certainly imagined, all your 2D phone screen type use cases could be useful. And then you can also have these holograms in the world, and they're world locked, and they're stable, and they stay where they are. And if we both had our glasses on, we could mutually enjoy them, explore them. If it's a chess game, we can summon it into existence and we can play it. And that's all very cool, and it can do those things. In the meantime, AI has come up, and we always thought it would be holograms first and AI would be later. And we have the holograms, but AI is coming up fast. And so I think a lot of the use cases that we'll use with this actually will be querying the world around you, querying your own day, your own past. Where did I leave my keys? Without having to separately do anything to remind it to remember where your keys were. It just has, the ability to keep track of these things by virtue of processing what's going on as you go about the day. And so that probably is, for me, the phone use cases combined with an AI that, unlike your phone, has full context on what you've been seeing and hearing.
Yeah.
Right? And how much more helpful is that going to be as an assistant as you go about your life?
While also doing the basic things that people expect a phone to do, phone calls.
Of course.
Video calls, seeing messaging.
Video calls are delightful in this. Can I just tell you that? It's such a funny thing. And that's where you see some of our other investments, like in our investments in codec avatars, super realistic avatars. Obviously, when you're wearing these on your face, you're not going to have a camera facing you. And one of the real delights is not taking a phone and holding it way out here. The muscles, arms get tired, I'm not that strong. And so we animate it by using a codec avatar that you've already created. And then the person you're talking to, it can fool them in the good cases. Like they will not necessarily immediately realize that they're not talking to a camera of you.
You talk about fatigue and the idea that you want to make these frictionless as possible, right? Seamless as far as and the wristbands here are part of that. Like the fact that you can control them. What are the kind of what's the end state of that? Because ML has allowed even basic gyro to infer tap gestures. Right?
That's right. Yeah, IM usage on the Apple Watch and other watches is increasing popularity for some use cases. I mean, we're really just getting started with this thing. So today, you're making relatively small gestures, and those gestures can be obscured from the hand tracking of the glasses, and they still registered. That's very nice. It's just the beginning. With this device, for example, we have working internally, like the ability to do handwriting. So you're already wearing this on your dominant wrist. You can do handwriting as a silent text input, and a very a demure text input, if you will. It's a very so with this device, we're only just tapping the beginning of it. The ability today to use these gestures that are very small and maybe even out of view of the glasses is nice. But that's just the beginning. You
want the ceiling to be raised.
Totally. In the future, this is a device that can do handwrite detection. So you can just handwrite, and you can do that handwriting very subtly and have it be text entry for the glasses that isn't this big dramatic, you're talking out loud or you're using a keyboard in front of your face. And so we see a huge ceiling in the neural interfaces.
And as you work to make this, smaller and thinner, and it's amazing that you said you already have plans or ideas to get this to even more compact, thinner, more socially acceptable. Which of these technologies make the most sense to distribute among the other products? Things like Meta Ray-Bans.
Absolutely.
What would be the easiest or things that make the most sense?
Yeah, and this is where the AI bridge, I think, is one of the really critical ones. So when you're building a device in a very phone-centric world, the Ray-Ban Meta glasses are a wonderful device. Of course, it's cameras, it's audio, it's really good looking, it's out of the way. You don't have to take your phone out of your pocket to get the image, to get the video, to take the call. As soon as you add AI, now they've transformed into a completely different category. Now you can query the world around you with the Ray-Ban Meta glasses, and you can do live translations with the Ray-Ban Meta glasses. Incredible. And that's just the beginning. What if you now had a simple small display? Well, when you have a phone already, a simple small display isn't obviously my favorite thing to add, because it's you can kind of look if you need to. But once you're asking AI questions and you get so annoyed with it reading you the answer back, even if it's reading the answer back to you exactly the question you asked, it's just takes time.
Yeah.
Just read it to me in text.
Binary, binary yes or no.
So much faster in text. Likewise, I'm taking an image, I want to share it. Is it good? I want to see it before I share it. So AI feels like this bridge use case that makes even smaller displays feel more valuable. And then those can get richer and richer over time, adding more and more value. And so while we are absolutely all, full steam ahead on the next version of these, which, we plan to have be a consumer product, we also are taking technology from this line and saying, hey, what is a miniaturized version of this? What's a version of this that we can take and integrate into are more affordable, already existing, very popular line of glasses.
Or somebody doesn't need to do everything.
That's right.
All these
the AI glasses have changed our outlook on the entire category. We were worried before that we would have to it would be a big gap between things like the Ray-Ban Metas and the Orion. And now actually we see an entire spectrum of products in the space.
And along the Quest ecosystem, those are parallel tracks that you guys see, not necessarily converging to a single product.
That's right. And they have a lot of relationships. So certainly when you're doing SLAM, VIO, when you're doing some of the work on coprocessors or custom silicon, on wireless, that work is shared between the two teams. That's wonderful. And there's a big base of shared work. But there's also a lot of work that is very different. And the thing that I think we're always very motivated by, who is the person whose life is better because this technology exists? What are they trying to do that is now better? And I think the use cases for glasses and for MR headsets is very different, even though they do things that look very similar if you write them down on paper. You can use similar words to describe them. In practice, they're very different. I kind of liken it to the difference between my phone and my laptop. I love my phone. I have it all the time. Sometimes you're on your phone and you're like, I'm writing an email, and you're like, no, this is a laptop email. And you're just like, no, your workload, I need to open multiple tabs in a browser. I need to be comparing things. I need to be doing research. I just need more real estate. That's a different job, and I use a different device for that job. I do sometimes make that analogy between AR and MR. They do some similar things, and that's great. We should make that as easily kind of transferable for the consumer as we can in terms of how it feels to do those things. But they also do some very different things. The ability to be completely immersed in a VR headset is a tremendously valuable asset. It can be done no other way, and you should build a device that's really, really good at that. Rather than trying to force everything into a convergence, which I think is a false convergence. Yeah,
and last question, the VR headsets, you guys do a great job connecting people. Seems to be a big mission statement for the company, remotely as they are physically far apart. Imagine if these become more distributed and more mainstream, how are these connecting people if people are sitting across from each other or in a co-located space?
Yeah, for me, it's two different parts of the story. I think one of which is, imagine we're distant. And certainly these can do video calls, and that can be very cool. And I can share with you what I'm seeing, which can be kind of a cool thing. We can do that today with the Ray-Ban Metas, and you can get on a video call and share what you're seeing with the person you're talking to. But a lot of this is also, when I'm with you, am I on my phone? Because if I'm on my phone, I am not with you. Physically, I may be here, but mentally, I am someplace. I've gone deep into the device. Whereas if I'm able to feel no, I'm on top of my things. It's all here if I need it. I hopefully am more physically present and connected with you because I have this technology versus the technologies that we use today, which are kind of famous for being not that. They're famous for being things that we kind of escape the present moment to get into. I'm sure this will be capable of both. If it's the case that I would prefer, I'm on a long car ride. Sure, let me dive into my videos and get my content, and it's all fine. But one of the things we do hope is these are technologies that don't just help people connect at a distance, but also help them feel connected when they're together.
And even if they're wearing together, there are features that will allow them to share the same content and see the same content.
I've gotten quite good. We have quite a few fun social games that you play, which when two players both have the Orions on, you can play these kind of games together. And two things are true. One of which is people on the outside, you look kind of ridiculous because you are doing a thing that they can't see the artifacts. And the second thing, which is more important, is even given the first, you don't care because you are fully engaged in a very cool shared experience that you are experiencing as very much as real as anything. So I think I think the world gets really fun when everyone has access to the holograms.
Can't wait.
Yeah, me
Thanks
too.
so much.
Cheers. Thank you so much. Yeah, cheers.
All right, let's dive into the nitty-gritty details of Orion and what it was like to actually use them and go through that whole demo process. I want to break this down into the 3 discrete hardware components that we saw and you've seen so far, and those are the glasses, the wireless compute puck, wireless being the operative word there, and then as well as these neural wristbands, these EMG electromyography wristbands that allow for one of the ways you can provide input to Orion alongside hand tracking, eye tracking, and voice, of course. Starting off with the glasses, it was very clear from everyone I talked to that the goal here, the stated North Star goal, goal was to have wide field of view in a socially acceptable form factor. And previously, you could have a 70-degree diagonal field of view. Magic Leap 2 had that, but you couldn't have that in a small form factor. Or you could have something that was more in the glasses form factor, like these X-Reels, but a fundamentally different type of augmented reality display system. This one using birdbath optics with the pros and cons of that. So Orion uses waveguides, and if you've been following augmented reality hardware, waveguides, as opposed to using a birdbath combiner, it's not having like displays that bounce through a series of mirrors to combine the image, the rendered image with the world image. It's using a display projector that shoots off axis, an angle across a either imprinted or etched guide, these pathways on some type of clear optical material, traditionally glass. And the material that's chosen has a certain property. Glass has a refractive index, I believe, of at most 2, which means that, and I'm not an optical specialist here, but the way I understand it is that limits the angle that you have to project the light into the waveguide, and also the degree and the field of view, the angle at which light can exit the waveguide into your retina. And with the higher the refractive index of refraction, the steeper the angle that you're able to get that light in, and then wider, then it bounces around to a point where you can have a wider field of view exiting here. So it combines the benefits of a wider field of view as well as a smaller form factor, the higher that refractive index. The waveguide material they're using here, it's silicon carbide. You may have seen that if you've looked around or watched videos or read stories about Orion. They're talking about what a novel material this is. And so previously, silicon carbide, as far as they know, not used in optics. It's used in EVs, for example. And there are a lot of these properties they talk about that make it ideal for AR. So high refractive index, it's very lightweight, lighter than glass, durable, stronger as well. And so you don't need to have things like flexures that around the actual frames to prevent it from cracking. It's all these benefits. It's just very expensive to produce. So when they talk about, somewhere around that $10,000 price point to manufacture one of these, 9/10 of that is actually in manufacturing, growing layer by layer, atom by atom, these silicon carbide waveguides, which have very low yields because you're generating them kind of off of a wafer. It's not like you can bin them and have some that are not as good that you can use in other products. They have to be perfect. And then they also go through a physically etched process to etch those waveguides at this nanoscale versus an imprinting of the waveguides in previous AR technologies. Long story short, a very complicated and expensive way to get this property, this lens property, that's allows it to be that smallish form factor. And I have to be upfront, my initial impressions and current impressions still of Orion is I don't think it's achieved the everyday wear form factor yet. Yes, much slimmer than, it's not the headset like a Vision Pro, it's not a headset like HoloLens or Magic Leap. It does look, it's closer on that spectrum to the Ray-Ban Metas, but there's still a little bit, the rims are still a little bit thick. And if you look at the profile, the side of the Orions, there's actually some thickness as well to the actual frames themselves. And that's because if you look up close, it's not just like one piece of glass or one piece of optical material. There's actually an optical stack that's sandwiched in those frames. I don't know the exact details of what every layer of that optical stack does, but my understanding is the frontmost layer can be like a polarized layer. So if you're using this outdoors, you get better visibility for the projected images. There's the display projector itself that has a live-up layer. So it's using here micro LEDs, not micro OLEDs that you might have seen on like the big screen beyond, or even the X-Real glasses. These are micro LEDs, and they're not organic. They are high efficiency displays that provide a massive amount of brightness. We're talking about in the hundreds of thousands of nits, which are required because that all gets reduced down as the light goes through the waveguide. So you're talking about a 300 to 400 nit display with the current implementation of the prototypes. That display projector lives in front of the silicon carbide waveguide, and then behind that there is a combiner as well that aligns and rectifies the display image with the outside world image, so make sure that that's all matched up. And then the closest layer also has things that support eye tracking. This is actually something really novel. The closest layer, if you look up close to Orion, I noticed like these little squiggly lines almost look like dust or hair lines. What's embedded on this frontmost layer of the optical stack closest to your eyes are tiny IR light emitters used for, of course, eye tracking, because you have cameras in the arms of the glasses looking at the lens. And so those tiny squiggly lines are actually the way those light emitters, IR light emitters, are powered, and they're squiggly because they have to be this randomized pattern so that when you're wearing the glasses, your eyes don't see the squiggly lines. You can't see them because they are a random pattern. So it's this really interesting idea of getting, instead of having a ring of IR lights that shoot into your eye beams, they're actually on the optics themselves, but invisible at that distance to the naked eye. I did ask about corrective lensing as well. If people right now are using contacts to use Orion, but they did say their plan, and a lot of their team do need corrective lensing, so that's something they want to solve. It's going to be built in. It's like a thing where you'll want to submit a prescription, and when it's in the assembly stage, the lens element that's closest to your eye will support some range of RX correction. They don't want something that you're going to snap on. They don't want an additional layer. It was really important to them, again, with trying to achieve this goal of having a display profile, a physical profile as close to glasses as possible. They want that distance between your eyeball and the lens to be 1.5 centimeters, 15 millimeters, which they're really proud of. Now, in terms of what this display looks like, 70 degrees diagonal FOV, so that translate to 60 degrees horizontal and 40 degrees vertical. In using the demo, it seemed expansive. And it wasn't that I couldn't see the edges of the limits of where it can render. If I move my head side to side, the images I could force a rendered window or an avatar I was looking at to be clipped off at the edges. But I don't need 90-degree field of view for augmented reality, as I might want more than that for virtual reality. I'm also wearing the glasses themselves, the frames themselves. You're also seeing the outside world. The benefit of having the real photons from the world come into your eyes means that as long as the rendered image kind of fits in that 60 by 40 degree field of view, it's wide enough to support multiple windows, to play a game, to not feel constrained, not looking like you're looking at a postage stamp version of a rendered image, as we've seen before in earlier optical AR headsets. It was also one of the best AR systems I've used in terms of not having a ton of visual artifacts. Now, it wasn't zero visual artifacts. I did notice some ghosting on the inner periphery. If I look, my eyes are there, like a ghosting of the image. But there weren't stray lights casting in. I wasn't getting like rainbow effects. So even though in some of the images that you may have seen looking into the glasses of like this kind of chromatic prism, it's not actually what I see as I was looking through the glasses, looking out into the real world. The actual holograms themselves were bright and not fully opaque, but had like a glowy look to them. One of the things I noticed was the resolution wasn't that high either. They're saying with the current micro LED displays, they're getting about a 13 pixels per degree density. So you could read some text, you could browse a web page, but it's not sharp. It's comparable to like early VR headsets. Like Valve Index is right around 13, 14 pixels per degree. They are working on different types of display projectors in the future. So I did get to try a 26 pixel per degree version of the Orion prototype, and that one was much sharper, although less bright and images also less opaque. So they're finding where those trade-offs live. When they want to ship this as a product, they're saying that they know the roadmap and there is a path to getting above 30 pixels per degree. They wouldn't want to ship something without that. They know that's a really important part. But the objects, they look there, they look present, but they're bright and glowy. It's not looking like, you wouldn't confuse one of those holograms with a real object in the real world. It's very clearly that holographic look of something that's very colorful and bright. The display system is also fixed focus, so it's not that holy grail of having some type of light field display where you can have version accommodation across any focal distance. The fixed focus here is 1.5 meters, so similar to VR systems, and they know there's a buffer, a range in which they can display content combined with stereo imaging that gives you comfortable 3D looking images without straining your eyes, without straining the accommodation. It is I think a limitation or parameter of the type of waveguide optics they're going towards. So these are not light field optics. I don't think we're going to get those in a glasses form factor, but it really was also emphasized how important it was that the display images, not only between left and right eye, but also with the camera systems, like outward world-facing camera systems, are perfectly aligned. They kept on stressing it is aligned to the precision of less than a tenth of the thickness of a human hair. Because any disparity, like vertical disparity between left and right eye, or disparity between the images and the world calibration, which can be affected by things like thermals, expansion of the hardware on a hot day, that would be uncomfortable because you also have the real world as a reference. And so the rendered images have to look perfect relative to each other as well as the real world. That's really important for AR. They could not stress heavily enough how important it was for that alignment to be in place. That's reinforced by the magnesium that they're using for the frames, as well as even some real-time adjustment and digital calibration based on the sensing of how the glasses are being worn. And this glasses form factor, which I think is probably the biggest this type of glass will ever be, hopefully, as they turn this into a real product. They did say that they had ways to make it thinner. Boz talked about not only they had ways to condense the thickness of the frames by maybe moving the projector instead of in the front of the waveguide to behind the waveguide, but you would need more calibration or real-time adjustment, but that actually gets you half the thickness. They also think the rims themselves can be less thick as well as a more ergonomically designed arms. So much of the physical ID is also constrained by how much electronics they need to pack in the ear and the power envelope of this. And so they've developed a bunch of custom silicon hardware to run things at very low power. So the display itself, that micro LED, that's consuming most of the power, but you also have onboard processing for SLAM world tracking, for hand tracking, for eye tracking. That's all running locally, spread across, weight distributed on these glasses. And then you also need battery as well. So things that traditionally would be consuming a lot of power on a phone, they're trying to get to a third, a fifth, or a tenth of power required. So the dozens of milliamps aggregated to a couple hundred milliamps versus a couple hundred milliamps aggregated to like a watt of power being used, because then you wouldn't be able to use this for the 2.5 to 3 hours of use time that they say those glasses currently have. So battery chemistry, there's just real physics limitations. The shape of the batteries, they can kind of mix around, but it's the classic, every cubic millimeter of space needs to be occupied and balanced in some way, and every dimension that you change affects some other factor. So that's I think the real breakthrough and innovation in the glasses part of Orion. It's not that it has the widest perfect field of view, or has the longest battery life, or the most powerful and smooth compute. It's getting all of those separate ingredients together in the physical limitation of that form factor that they've been able to achieve, and then they can say, okay, now that they got 70-degree diagonal field of view in this 98-gram package, where are the places they can tweak to make it more affordable as a real consumer product. And a lot of that has to do with the second device, the compute puck as well. So while there is local processing on the glasses for things like SLAM, app logic, so what actually runs applications, things that don't need immediate low latency that would make it uncomfortable to use in AR glasses, that can run on a wireless compute device. And it being wireless, such a big deal. They talked about how they've created a unique protocol that works on top of Wi-Fi 6, where they're pulsing the data, not streaming data nonstop, which gives them a lot of power savings, and then of course tuning the applications to work with that. The compute puck is something, because it's wireless, it doesn't even need to be in your pocket. It can be in a bag. They talked about it being in a backpack or a purse with a range of about 10 to 12 feet. So that can last all day, while the glasses can last a couple hours. And something that, as long as it's close to you, you're going to get that full functionality of the glasses. An interesting side note with the compute puck, you'll see in some of the video that we shot of it that it looks like there are cameras on the front of it as well as on the side on this bevel. And those aren't actually cameras in use. Those are actually artifacts left over from earlier implementations of explorations of how they could use this compute puck. And if you're thinking it as a controller, they also thought of it as a controller. The cameras on the front and maybe the little divot on the top of the compute puck in previous versions, allowed to work as a 6-degree of freedom tracking precision controller, kind of like a Touch Pro controller that you got on the Quest Pro, inside-out tracking on the device itself. They decided they didn't want to focus on that. That was maybe too much, spreading too thin, so they have hand tracking instead. The cameras on the bevel in front of it were to maybe place it on a table so it can look back at you and do some kind of skeletal modeling, so that when you are on a video call, your avatar could be fully tracked. But they also didn't want you to have to require, they wanted this to be a device that you can be using while walking around and not have to require taking the compute puck out of your pocket, putting on a bench or a table just to do a video call. So making those very deliberate decisions to then rely on the camera systems, on the headset itself, inferences that they can then use, extrapolate over machine learning for things like body tracking, face tracking for their codec avatars. But really cool to see some of those design decisions that they explored still on the prototype hardware itself. So the compute puck doesn't do the input. And while there is eye tracking input that we talked about, there is hand tracking input. You can combine those very much in like a Apple Vision Pro way, gaze and tap and pinch or moving things around. There's also this wristband. So it's also the first time we're seeing in a product the investment they made when they acquired Control Labs, and they've published papers since then about EMG wristbands. So this is a wristband that uses a non-invasive sensing of the electrical signals that go to your muscles in your wrists. So the complex sense of array of muscles that are moved as you move your fingers or the orientation of your hand, that can get translated and processed through their ML processor on board the wristband itself, and then turn into gestures and poses that the system can recognize. And I was really curious, because they invested in this EMG system many, many years ago. I'm sure they've spent a lot of money developing it, but machine learning has also gotten a lot more advanced in the past couple of years. And something as basic as an IMU, a gyroscope, an IMU inside, like a watch band, we've seen with demos at Augmented World Expo, even in accessibility options on the Apple Watch, you can get tap, pretty reliable tap gestures without needing to tap into EMG. The IMU can actually be trained, that data can be trained to get you a pretty good success rate. What Boz and the Orion team told me is that the potential of what the wristbands can deliver over time, that ceiling, has so much promise, so much potential. The very basic gestures that I was used with no system training, no calibration training, it was just tapping. So I could use a thumb to index finger to tap, and this doesn't need to be in front of me. It can literally be in my hand in my pocket. Imagine I'm just walking down the street, hands in my jacket pocket, and I can be controlling the interface with taps. I can be turning my wrists and tapping my thumb to my middle finger and bringing up a menu. I can be scrolling. So one of the most impressive gestures was just putting my thumb on my index finger and swiping up and down and scrolling through like an Instagram video feed. I really tried to see like how much pressure, how much intentionality did I need to put into that gesture? And it turned out not much at all. Just that gentle, small micro gesture, as they would call it, was enough to get scrolling. And that's where it seems to be a very powerful form of input using your hand versus the computer vision based input, the CV based input of the hand tracking on Apple Vision Pro. I've loved the Vision Pro's combination of gaze and pinch and gesture tracking. It's been really intuitive and really powerful to use, but over this past year of using that, I've also realized that a lot of big movements in my hands are still pretty straining. So, grabbing something, pinching something, and moving it with my elbow or moving with my wrist, which I do more than I probably should, that's not comfortable over time. It's really that our hands are built for the dexterity of our finger joints and our finger movements. So that's why, holding a stylus, holding a pencil, it's about moving your finger knuckles, not about moving your wrist. When you're typing on a keyboard, you don't want carpal tunnel. You want to be moving your wrist. So the micro gestures, the smaller the gesture that you can make that the system can still interpret as these separate, discrete input types, the more powerful and the more comfortable and more long-term use that you can get out of this, which you'll need for augmented reality. And that's why they're committing to this EMG wristband. I did ask about multiple wristbands. Right now there's one, and it's a very svelte form factor, but they've showed demos of people using 2 wristbands. They talk about in the future being able to recognize handwriting without actually physically writing on a piece of paper, and they've even have trained versions of this where someone can be typing on a keyboard that isn't there. Didn't get to try any of those yet, but for the basic gestures of tapping, of opening up a menu, of swiping, of double tapping for tapping into Meta AI, all of those work with 1 or 2 false positives, even like kind of the small ticks. I had my arms folded and, just moving my hands, rubbing my hands together. I was activating their Meta AI accidentally. So something I'll probably have to train myself to use for the system, as well as the system learning my own proclivities for how I move my hands. Lots of interesting tech there. And then the demo experience itself. There was an onboarding process, so a whole fitment process where they got the glasses to work with my face. The arms are bendable, so they do bend outward, and they bend not at the traditional point of where a hinge would be. It's lower, and that's probably for the added rigidity, again, for the two display systems to be calibrated and the cameras to be calibrated. But they did give me a nose bridge so it would stick to my nose, as well as these rubber grips to make sure that the glasses arms weren't moving. Because the way their eye tracking works, I got a sense that if I was like pushing the glasses against my face from time to time, I would lose eye tracking calibration and have to do that process again. It was a very on-rails demo, lots of guardrails. They walked me through this very evenly diffuse lit room, so no bright lights, lots of hard angles, probably help with the SLAM world tracking. They walked me through, from a couch to a little display area they had set up. I did very basic things. There was a video call, so chatted with someone in which they would have seen a codec avatar. Now, interestingly enough, the 7 camera systems, there is no camera system pointed down your face. There's no face tracking camera like the Quest Pro or the Apple Vision Pro has. So that's probably using your voice and then using machine learning to convert that into mouth movements of your codec avatar, which probably is rendered in the cloud and then streamed down as video. So it's not like a spatial persona per se. It's still in a video. But you had asymmetrical experiences where I was doing video calls with someone just holding up on a phone, a video call with someone in a codec avatar, again, a flat codec avatar, and then things like web browsing, video watching, all of which looked and worked as kind of, I would imagine. So, I'm speaking about it very plainly and almost like unremarkably, and the amazing part was how kind of natural and unremarkable, how the experience matched in my brain what I hoped it would be. Performance was a little bit laggy. I could tell not that there was the latency between the glasses and the wireless compute puck, but maybe they're pushing the limits of how many windows they could display, and I didn't get a sense of the frame rate of the images. It wasn't like dragging a window; things were lagging behind, but it was only the 3 panes. They were locked in line to each other, kind of like your Quest dashboard. And even though I could put that alignment of 3 windows anywhere, it wasn't locking those windows to the room mapping, for example. I get to use one instance of Meta AI where, like the Ray-Ban Metas, I asked it a prompt to look at the scene in front of me in this guided demo. It was a scene of ingredients to make a smoothie. And then it did the thing where you could hear it take a picture, a shutter snap. It would process it. And after a couple seconds, I would get these indications on top of the actual objects themselves, labeling. So the cool thing here was, as opposed to getting audio feedback, which you can do right now with the Meta AI on Ray-Ban Metas, it was actually world-locked visual feedback, identifying each of these products on the table with a label that was attached to them, and then a floating list of like smoothie making instructions. That type of world locking is what we want from AR, and we want more of that scene recognition, scene understanding, persistence. And my sense is that persistence isn't there yet. It's for the duration of that interaction with Meta AI, but it doesn't have the capabilities to know that I want this XYZ recognized and have it, persistent as I'm walking between rooms or walking the outside world, continuously track, continuously updating. That might be more for, as you get more compute, or are they figuring that out later? I did a demo where I was sitting at a kind of a high bench coffee table and then, scrolling through social media. So scrolling through Instagram, again, here using the very small micro gestures, just swiping up and down. That was one of the breakthrough moments for me, how easy, intuitive, and not laborious, unstrained my hand was, just doing these micro gestures. It was really amazing. And then there were some games. So they had this kind of 3D game that you kind of place anywhere, and it's an eye track and then tap-based, gesture-based activation where you're looking at, where you want the enemy, your spaceship to shoot. Very simple kind of asteroid-style shooter. Not super impressed with that, but the final demo, this Pong demo, that one blew my mind. That one was done in 2 ways. One with co-location. So with the project lead Orion giving me the demo, looking at him, he's wearing Orion glasses. I'm wearing Orion glasses. And between us are 2 glowing grids that are locked in place for both of us. And with stereo, there's real sense of depth there, and this glowing pong ball that's going between these 2 squares, glowing blue and glowing orange squares, and then using my hand to kind of move a gesture and try to spin that pong ball as it moves through 3D space. That seemed so futuristic, so science fiction. It was amazing. And then looking around the room, and of course everyone looking at us, and they just see 2 people holding their hands out, playing, waving in the air, looking like we're waving at each other, but we're playing a multiplayer game of holographic Pong. That was so cool. I did another version of Pong where instead of playing with someone in the space, I was playing against a stylized full body avatar. And that avatar was maybe standing, 7-8 feet away from me. And here with the 40-degree vertical field of view, I could see the avatar in its entirety. It was there, and I didn't need to look up and down and have their head or feet cropped off, and have them, fully animated with their hand tracked as well, and talking to them with spatial audio. It was like a holographic presence. It wasn't the photorealistic codec avatar. This one was way more stylized and glowy, but it gave that sense of, if you, again, over time with more compute, having more of those walking around in your space, that feels really like the holodeck, like science fiction. Throughout my entire demo session, it was continually reinforced to me that as impressive and as proud of this prototype that they spent so many years on, they know they can do better. They know the paths forward to make it more of a consumer device. And I think it's a really good decision that even though they originally intended to make Orion something they could sell, that they're not selling this right now. If I was to imagine what a consumer version of Orion may look like, I don't think it's going to end up using that silicon carbide. I think that they're realizing that the benefits of it, that wide FOV, like the costs are too high. They're not going to be able to scale that and make it affordable. So you might have a little bit of a lower FOV, or they find the trade-offs that they have to figure out. They know they need a higher density display. They want to ship something with at least 30 pixels per degree. So it might not be as bright or opaque as the holograms I saw in this demo. But they also know they're going to get a smaller form factor with a thinner optical stack with thinner bezels and more ergonomic arms. And it seems like they're well on their way to figuring out what that means as a product, because they really want this to replace the phone. And that also means they want to charge a lot of money for it. It's not going to be an accessory that you buy just to use on airplanes or in the car. They want people to buy these as maybe their second most important computing device. And they talked about maybe pricing being in the range of a high-end phone or laptop. So in my mind, maybe like $1,500 to probably $2,000 is where I could see this ending up. And I would rather that they charge more and make sure they include as much of that technology as possible than try to get something that's more mass market appeal and not have the experience be as good. But I'm also super excited about where the technologies that they've built into Orion are going to make their way into Quest products or Ray-Ban Meta products, specifically those EMG wristbands. I would love to have micro gestures I could use while using glasses to peruse, some type of social media feed or scroll. Have another way of doing input as opposed to just tapping the sides of the glasses or just using voice control for their AI system. So it'll be a ways away, I think, before we'll see the consumer product that Orion ends up being, and this prototype they've made, the 1,000 or so that they've made, are not for developers. Unlike the Snap Spectacles that were announced a couple weeks ago, developers can't get this right now. It's not about building an app library or an app store. When we think of the iPhone, that killer app on the iPhone, yes, it's the App Store. It's the thing that's made it so powerful. But when the iPhone was announced, Steve Jobs walked on stage and he sold it as a iPod, a phone, and a breakthrough internet communicator. And it was about getting the fundamentals right, having real value and utility in the device out of box so people will keep on using it rather than trying to put it out there and figure out, let developers figure out. That will come later. So Meta, Orion team, take your time, get those tech into things like the Ray-Ban Metas, into Quest, and I think they're well on their way to bring us the future. Hope you enjoyed that deep dive into Orion. If you have questions about my experience, please post them in the comments below. I'll try to reach out to the folks at Meta to answer those as best as possible. And thank you so much for watching. As always, I'm Norm, and I'll see you next time.